Good morning, everybody. So, I hope you have enjoyed this long vacation and is ready to go back to work. So, let's start with Unit 4 Forces and Motion. Today, we will be looking at the difference between mass and weight. And at the end of this video, you should be able to differentiate between mass and weight. And you also should be able to convert mass into a weight and weight into a mass. So let's look at the differences between mass and weight. Mass is the amount of matter in an object, whereas weight is the amount of attraction on an object caused due to gravity. Mass is measured in kilograms or even grams, whereas weight is measured in newtons. Now, there's a new term, gravity. What do you mean by gravity? Gravity is the force of attraction between two objects that have a mass. So the key words here is attraction. It is a force of attraction. And then you have between two objects. And the other key word is that should have a mass. So simply, gravity is a force of attraction, or it's a force between two objects that have a mass. And all objects are attracted to Earth by gravity. That is why you are able to stand on the ground without floating. So bigger the mass, bigger the force of attraction towards the Earth, and therefore bigger the weight. And then there are more differences between mass and weight. So except for the definition, you know that mass is constant. That means it does not change. So your mass in Earth, so your mass on Earth will be same as your mass in the moon. Whereas your weight would depend on gravity. Therefore, you will have two weights. One weight in Earth and your weight will differ in moon because it depends on gravity, and gravity would differ from Earth to moon. And then you know that mass is measured in kilograms and weight is measured in newtons. Please remember this. And weight is measured in newtons. So why Newton? From where did Newton come? Weight is actually named after Sir Isaac Newton. He is considered as the father of modern physics, and he is the one who found out gravity. Therefore, in order to honor his name, we measure weight by newtons. And then, since mass and weight are two different entities, we use two different instruments or apparatus to measure them. So force meter is used to measure weight. Remember that, force meter. So here if you see, it is actually given in newtons. The reading is given in newtons. Whereas mass you can measure using a scale. So this is like in the picture you can see a old type of scale, but pretty sure you all have seen electronic scales in your kitchen. So let's go to space for a moment. Now you know that gravity is the force of attraction between two objects that have a mass. So any two objects that has a mass will have a gravitational attraction between them. So why doesn't the moon come and crash on the earth? The answer is that earth does try to pull the moon, but moon is small and far away. So the earth's gravitational force is not enough to pull it towards the earth. Therefore, the moon rotates around the earth in a circular path, and we call this an orbit. So this dotted lines actually shows an orbit over here. Then, if you need more further information on this, you can click on this video attached to this slide and go ahead. Right, now we come to a very interesting question. Which has a larger mass? A 10 grams of feather or 10 grams of sand? try to take it. Try to measure 10 grams of feathers and put it into a bag, and then take 10 grams of sand and put it into a bag. But what do you think? If you keep the 10 grams of feathers on a scale, on electronic scale probably, you will get the reading as 10 grams. And then if you keep the bag of sand, you will also get the reading as 10 grams. So that means mass is constant. Mass doesn't change. But if you look at the two bags, you will see that bags of feather is big, fluffy, whereas the bag of sand is small. So the volume that it occupies would differ. So this is actually very important for you all. You must remember that 1 kilogram is equal to 10 newtons. So you will get conversions where you have to convert kilograms to newtons and newtons to kilograms. So if you remember this, you will be able to do it very easily. Alright, so now let us do some conversions. So you all need to know how to convert kilograms into newtons and newtons into kilograms. So look at the first example over here. First, you need to write down the golden rule that we learned earlier. 1 kilogram is equal to 10 newtons. Then 2 kilograms is equal to how many newtons? In order to do this, we have to cross multiply. So 10 newtons by 2. 2 into 10 is equal to 1 into A, or any letter. Then we know 2 into 10 is 20 and 1 into A will be A. Therefore, A will be equal to 20. So we can conclude that 2 kilograms is 20 newtons. Then we move on to the other way around. So now we are trying to figure out 25 newtons is how many kilograms. Similarly, we write the golden rule first. 1 kilogram is equal to 10 newtons. Then A kilograms is equal to 25 newtons. Then again we cross multiply. So remember that you must always write down newtons and newtons in one side, kilograms and kilograms in one side. Do not mess this up. Otherwise the whole calculation will be wrong. So 20 into A will be equal to 25 into 1. So 10 into A will be equal to 25 into 1. So 10A is equal to 25, whereas A will be equal to 25 divided by 10. You all know that when something goes this side from the equal sign, we should do the opposite operation. So that means opposite of multiplication is division. So that is why 25 is divided by 10. So A is equal to 2.5 kilograms. So we conclude that 25 newtons is actually 2.5 kilograms. Simply what you should do is when you are converting kilograms to newtons, you multiply. When you are converting newtons to kilograms, you divide. I hope you understood it. Here are some questions to try at home, and if you need any further assistance, please feel free to contact via LIMSOL. And yes, there's 2 activity pages to be done. Hope you will enjoy.